All right, welcome back. We are Game 3001 in the fall. What fall? Summer. My mind is already on the fall. Summer 2022 semester at George Brown, and it's week 12, believe it or not. Part one of our broadcast and recording. And again, on Thursday, we'll do um, the lecture together. And I'm going to go over a couple things today in terms of our lab. I got a couple questions here from different people about assignment 3. Again, the hard stop date for assignment 3 is this Wednesday. That's tomorrow night at midnight. So if you haven't submitted assignment 3 by now, then your last chance is tomorrow night at midnight, and then the Dropbox will close. Okay, so that's how that's working. We're sitting at, again, week 12. Last week, we talked about behavior trees and different kinds of nodes. I kind of recommended a map of what it might look like if you're going to use a behavior tree for assignment 4, possibly. And we built in lab 1, lab 7 part 1, built a tree class, added conditions and actions, and we're going to do more of that today. This week is all around something called goal-oriented behavior and rule-based systems, which we'll talk about on Thursday. And we'll do, of course, Lab 7 Part 2. On the horizon is Assignment 4, which is due all the way in week 14, so that we're sitting here at week 12, a couple weeks from now. Sunday, August 14th at midnight is the due date for that one. Okay, so let's get to it. In terms of our final bit, what we're doing today is we're going to be talking about removing the build tree function from the decision tree and basically adding it to both to individual enemies that we're going to create. We're going to create a close combat enemy and a ranged combat enemy. That's what we're doing today. And we're going to basically add the decision tree to the enemy as if it's its brain, the enemy's brain. So that's kind of how it's going to work. Again, this is in to assist you with your assignment 4 that we're working on together. Okay, so that is what we're doing today. So let's get to it. In terms of the instructions, okay, here are the instructions that I've posted. Again, up on the Lab 7. I've updated Lab 7 with a couple of things. If we go there, let's go there now. So Lab 7 has, if we go to Labs, if you somehow missed last week's session or you couldn't get it 100% working, and this is your last chance, to start with the starter. So I won't do a starter for next week. It'll be based on this week. But the great thing is, at least if you haven't had a chance to do Lab 7.1 or didn't make it work, then I've posted a solution for Lab 7.1, which is Lab 7.2. So you can start from there, which includes most of the files and changes that we made. So that way, worst case scenario, you have a chance to catch up. Most of you, though, were here last week, so that's good. And it's always good to practice because it makes you a stronger programmer and build your confidence, which is what we want you to do in all these labs that we're doing together. Okay, so that is where it is, and there's your instructions for that one. So for me, what I'm doing is, if I kind of go up here, I have copied Lab 7.1 from last week, and I created something called Lab 7.2 this week, but it's really just Lab 7.1 copied. That's all it is. So I'm just kind of moving in with a new one. And I'll post the changes here to Lab 7.2 so that way you can follow along with GitHub. So again, for GitHub, what I'm doing this week or this semester is I'm just using command line. So I'm going to do cd space, and I'm just going to drop in my section 1. There it is. And I'm just going to do a git add dot git commit -m, and I'll say added project files for Lab 7.2. So that's it. And then I'll push, git push, and that'll push everything up to GitHub. Okay, so that should be pretty good. Not a lot of changes there, and we're ready to go with that one. So again, I'm starting off with Lab 7.2. This is the structure. Nothing's really changed in terms of files or anything. We're going to add stuff as we go. I'm going to keep this up, so I'm going to refer to it again. And we're going to start with our instructions. So again, we're going to use your completed Lab 7 Part 1 to start. And we're going to do some stuff there. So let's get into that. Here's our Lab 7.1. And a couple of changes I'm going to make. We're going to start with an enumeration change to the action state. So action state right now, we have no action, attack, move to line of sight, move to player, and patrol. And what we're going to do is we're going to add in the move to range action. Okay, so that's the new thing that we're going to do, because we also are going to put together a close combat, a range combat enemy, and the range combat enemy has something called move to range. Okay, so that's what's going to be in there. I'm just going to put it in here in order. So that's where the move to range action enumeration is going to be. So let's save that. Okay, that's the first one. And then the next thing is we are going to comment out the build tree function in the decision tree.cpp. Okay, so that's what we're going to do next. So it won't be functional the way it is right now. So if I go to decisions, right, as an example, you can see I have decision tree.h, and under decision tree.h, I have a build tree function. We're just going to comment this out. This was just to make it work last time. Save. And then we're also going to change the decision tree, the body of the decision tree itself, and just comment out all the places where we called build tree. So just there and there, as well as, of course, the entire function should be commented out. So let's do that as well. And the reason why we're commenting it out and not deleting it is because we're going to make a copy of this into our different, other individual agents we're going to be creating. So that's what I've done there. Save. So we've commented that out from the decision tree. So I'm just going to close that off there, and action state is done. And the next thing is, it says remove all references to the decision tree in the placing.h and CPP. So that's the next thing we're going to do. So we're going to go into the placing.h, and we're going to remove any references for the decision tree. So we're just going to do that. And this is going to cause an error that's going to appear here for decision tree, where we're going to just actually delete this one. There we go. And then when we do that, save, we're going to go back to the placing.cpp, and you're going to see that there is another area here where decision tree is going to have to be removed, as we don't want this to happen. So we're just going to go decision tree, goodbye. That is definitely a place where we don't want that to be. So we're going to get rid of that in the placing.cpp, as well as in the update function. Those are the two places that we had our agent making a decision, and now it won't do it. Now, at this point, you should still be able to run your code without anything breaking, because all we've done is remove stuff. We haven't really added anything. So if I click play, if we did everything correctly, if we removed everything right, then it should be no problem. We should still be able to run things, but our agent will not be able to move anymore. So there's no more patrol because they don't have a decision to make, right? So that's what's going to happen in a second. And let's take a look. Again, building is always vital, as it will tell us if there's any kind of errors that we have to deal with. So again, last day we had something like this, and you can see that there's no movement anymore for the agent because we've taken away their decision capability. All right, so that's where we're starting off. This is a great place to make another commit, as we've removed stuff from before. So again, what I'm going to do is I'm going to go here and git at dot git commit -m, and I'm going to say something like removed decision tree from placing, which is really what we've done. Git push. Okay, so that's the first commit we've done, and we're sitting here at this point right here. We're done the setup. Now, changes. Okay, so what we want to do today is going to be slightly different than what we've done before. So what we want to do is have a couple of different things here. I'm just going to show you the completed project. So it's going to look like this. You're going to have another type of ship, which is kind of like this is your one type of enemy that we have, close combat enemy type, right? And you can see the only time that we want to have the line of sight showing is if we toggle on and off the I am GUI scene. Okay, that's one thing we want to do. We can toggle the grid on and off like normal, but now what's happening is as soon as the other agent sees us, as an example, then they will stop. Notice it says this is a close combat enemy, and they will be performing move to player actions. So that's what they're going to be doing. That's the first thing. And if I move my player around, they're going to try and find me again. So if I take my ship around and I move it, let's say here, it's going to try and go in there. And if I move my target, which is my ship, over here, it's going to continue to move and patrol until it finds me. And you can hear the music in the background has changed as well. We're going to talk about that in a bit, because now it's more of a combat scenario than more of a patrol. Okay, so you can see as soon as this one has line of sight and is in range, notice the range is limited, it's only up to there. As soon as it becomes in range and it has line of sight, then it'll stop. That is the condition. Notice it's in patrol action right now. That's what's going to happen. And as it hits this area here, it's going to stop. And the new action is move to player. Now, we don't have a move to player action, but it's there. Okay, so that is the first thing. And what we can do, and this is a beautiful thing, is inside of our play scene, I'm just going to do it here off screen. Inside of our play scene, what we can do is we can set up a different kind of enemy, right? So right now the enemy is kind of a close combat enemy. And what we can do instead, I'm just going to just set this up here so you can see what I'm looking for today. What we're going to do is we're going to set up just a momento. I want to set up a new type of enemy, which is the ranged combat enemy. So let's just do that instead and comment that out. And I think we need to do the same thing in the .h, just 1 second, and then you'll see the differences between one kind of enemy and the other. So I'm not actually making it so that you have both enemies in, just one. So here's what the ranged combat enemy would look like when we switch it up. So when I switch up between the close combat enemy and the range combat enemy, there's going to be a different behavior that they're going to exhibit, and their idea is they're going to keep their distance. So that's going to be the new behavior, and also represented with a different texture so that you can see the difference. So again, you can see here that we're pretty good, but the difference that you have here is what's actually showing in behind, which is range combat condition is happening as opposed to the close combat condition, and then it says performing move to range action. So that's what it would do. It'd keep its distance, and it's playing a different action, which is what we want to do. We want to play different actions depending on the type of enemy at this point. So that is the difference between what we have today and what we're going to get to, at the end of the day. Okay, so there's where we are, and there's where we're going. All right, so again, we've cleaned up the placing. We can close that off for now, and we've cleaned up the action state. And the next part is changing the agent to include a few more additional actions, because if we're going to bury the brain of the decision tree inside of each of the agents, it makes sense that all agents should have access to those action functions. So let's do that now. So I'm going to go to my decision. I'm going to go to agent.h. And here, like it says, the first thing I want to do with agent.h is include the obstacle.h reference. And this is because we're going to have to, they need to know, agents need to know about obstacles at this point too. So I'm just going to copy, I'm just going to kind of put in the obstacle.h kind of information there. That's the first thing I'm going to do. So there's obstacle.h. And I'm going to start setting up the action functions, and we're going to talk about that. So set action and get action is cool, but what we want to do, and if we look at all of this, we have an action state at this point. We have all the regular things we had, collision, whiskers, and blah. We haven't removed those, line of sight distance, and the current direction, and blah, blah, blah. None of that is really changing, but what we want to do is we want a new utility function that we're going to put in here. So this is going to be new for lab 7 part 2, and that is going to be a new Boolean function that's going to be called check agent line of sight to target, and that is going to have an agent as an example, a display object pointer that's going to be the target object, and I'll explain this in a second, as well as a standard vector of type obstacle pointers, okay, which we're going to call, we're going to get a reference to that, and we're going to call these obstacles. So we're going to use this to make sure that whatever obstacles are in the scene, that the agent is going to be able to navigate around them and check to see if there's line of sight between the agent and the target through the obstacles. So that's where we're going to add it into the agent to, kind of include, different opportunities for us to see those things, and to have the brain, the agent's brain, work with a check line of agent to line of sight function. Next, what we also want to do in our Lab 7 Part 2 is we also want to include virtual functions to be overwritten by other agents, which are the attack action. So this is the different methods we're going to have. A virtual void move to line of sight action. Oops, there. Maybe if I can spell that properly, that would be good. Something like this. Move to line of sight. A virtual void move to player, right? Action. That's going to be it. A virtual void. These are all the action methods. A virtual void move to range. So those are them. And then finally, a virtual void patrol. Okay. And what this will do, if we add these virtual functions, okay, so this is a utility function. So utility, more like to help us, right? And then we're going to have virtual functions. So virtual functions are there. So when we inherit from our agent.h, the virtual functions means that all of these, game objects that inherit from agent also have these virtual functions in their life cycle, which means I can define these specific actions for every subclass. Example, close combat. A close combat enemy will have attack, move to line of sight, move to player, move to range, and patrol. But as an example, move to player, the close combat enemy will use, right? But they won't use the move to range typically. Okay, so that probably will not be defined. And at the same time, we'll also have for the range combat enemy, attack, move to line of sight, move to player will not be there, but actually move to range will be there, right? For the range combat enemy, and so on. So that way, you'll have these functions. I can call these functions outside of those classes because each one of them will have it. So it'll reduce some of our casting and everything else that we've been doing so far. Okay, so that is the start of those things. We're adding it into the .h. Just going to go back to here. So we added this. We added new empty virtual action functions. We didn't make them pure virtual because that means they must be overridden. And we're going to add a prototype like we just did for the check agent line of sight to target function. And we're going to refactor this in a second. And I'm going to build the check agent line of sight to target now, and kind of get that all built out before we commit. Okay, so let's do that next. So what I want to do is I want to go here and I want to click on the little hammer and go generate definition, which is going to generate it inside of our CPP, or agent.cpp. Let's code that up and let me explain what this is going to do and what that looks like. Okay. So again, if I look at that particular function, what it's supposed to do for us, right, this check agent line of sight to target, is very similar to what we already have. Okay. So we kind of have something like this. Do you guys remember where we have this check agent line of sight to target already? Do you guys remember? have something like this already. Where would it be? Placing. Yep. So if I go to the placing.cpp, right, and if you scroll down here, right, as an example, and if you look at some of these things, we have some keyboard input and build grid and toggle grid. Then we come to this one, check agent line of sight. And it looks eerily similar to what we're going to need, right? So there's our check agent line of sight. And you can see that the check agent line of sight has a bunch of stuff here, right? That's built in. And a lot of it is very similar. One thing that we notice is that an agent in the target object are, again, very similar to this. So it behooves us to, instead of like recoding everything like this, it behooves us to just do it all, like copy all this stuff and move as much of it over as possible to save time. So that way we don't have to do it over. Also, if we look as a note, so that is the placing. If I go to decision tree.h, decision tree.h has none of that. It has make decision. That's what it does. And if I also look at the our friend, which is the starship.h, starship.h has a build patrol path, right? But there is no check agent line of sight here because it should belong for all agents, not just the starship. Okay, that's how it should be. Fabian, note we're using the same base files as we did for lab 7.1. I've just provided lab 7.2 so that way you guys are good to go. If you just couldn't get lab 7.1 going, you can start off with lab 7.2 starter. It's up to you. But I recommend, kind of moving it on from where you were, and that's kind of a better way of learning. Okay, so that's where we have it. So we already have it here in our placing. Why don't we just lift it out of here, this whole part, and we'll make some changes that make sense. So copy all this, right? And I'm just going to go over to my agent.cpp here and just paste it inside of there, like so. So the first part, bool has line of sight is equal false. The default is true. That should be good. One thing that that we should put in here is I thought we had it somewhere else as well. I thought we had it more anywhere, but we'll adjust. It doesn't matter. So we want to get a couple of things. So this is correct. And agent is this. So set has line of sight, to the agent itself. We could certainly set that up here at the beginning. So we kind of set has line of sight. Because this is the agent, we don't have to say agent anything. All right, that's one thing we have to do. And line of sight color, we can certainly put it up there, and we can change the line of sight color as we go for the agent. So that's okay. That's same, no problem there. The other parts we need are some of the other things that are missing. So, for example, we are missing the target direction. Okay? And the target direction, again, is a normalized direction. So it is the target object and the get transform dot position minus the our agent, which is this, our get transform dot position, because we're in the agent class itself, right? And that is the whole distance. So target direction is the whole distance. We need the normalized target direction, remember? So the normalized target direction looks like this, normalized direction. The normalized direction is we're going to use the util class, util normalize, and we've kind of done this before. And we're going to pump in the target direction. So this, what it does is it points to the target. And when I say points, it's a vector of magnitude 1, okay, which means it's only a one, kind of a 1 pixel length. That's what the normalized direction is, just a pointer. I'm also going to set the middle line of sight endpoint to get transform dot position plus some normalized direction, and then times the get line of sight distance, which is the distance between the farthest line of sight distance that the agent has, which means how far they can see. Okay, so one thing is, do they have line of sight, and the other one is, what's my range? How far can I see? Beyond that point, it's just too far, right? Next, if my agent to range, we're going to use the get closest edge function that we had before, and we're going to use we don't have to use agent there, we can just remove agent, get transform position, and the target object, that is all correct. If the agent to range is less than the get line of sight distance, again, we can remove references to agent, then we are in range, and then we can create a contact list of display objects that are here. So this is the target. And the display objects, by the way, when we create a display object, now this is where it gets tricky. For display object, we don't have access to the display list. This would have been cool if we were sitting inside of the placing, but unfortunately we're not sitting inside the placing anymore. So this is where we need these obstacles. So we're going to say, instead of our display list, we're going to say this is for every obstacle in obstacles. So here's our obstacles. That's the obstacle list that we're just passing to this as a reference only, right? We're not making a copy, we're passing it by reference. And then we can refactor rename this one. So we'll say refactor rename, and we'll just call this the obstacle. For every obstacle, right, in obstacles, that's what this thing says. And this could be const. There we go. For every obstacle in obstacles, the next thing is inside of here, we're saying if my, there's some changes here. Agent to object distance, right, is something that we want. And we're saying if the agent to object distance, and you're looking at the get closest edge, we're kind of doing this. What this says is if that thing that we're checking, agent to object distance, is the closest edge between where I am right now and the obstacle that I'm looking at for each of the obstacles. So that is the first thing. That's the agent to object distance, right? And then what I'm saying is if that agent to object distance is greater than the agent to range, then continue, skip over this part, right? Because we don't want to be able to do that at all. But we also want to, so another thing that we could also do is we could also check to see if each of the obstacles inside of this for loop, the first thing we can do, we can say if our obstacle get type, right? So obstacle get type, if it's equal to none, so there's no type, right, as an example. And of course, it's game object type none is what we want to put in there. Then we also want to continue. So if it's something like that, we don't want to use it. We want to skip over that one and not add it to the list. And notice that here we had different kinds of checks we're doing for the obstacle. Is it an agent? No. Is it a path node? No. Is it a target? No. Well, then it must be an obstacle is what we're looking at here. Okay, so that is what we're checking. Okay, so that's for every obstacle and obstacles. And then we say is if it's none of those, right, then we don't have to check some of this other stuff, because before, when we were doing this inside of the display, inside of the placing, we were looking at a display list. Here, we're not looking at a display list. We're looking at a set of obstacles already, and we can make this also const for now, this little thing here. So we don't need to check this anymore because we know that it's an obstacle. It's not going to be an agent. It's not going to be a path node, right? It's not going to be a target. It must be an obstacle because those are the ones we're passing in. So we don't have to do this extra branch. We can kind of do this and reduce it so that it looks like this. Okay, so that's something we can modify as well. Okay, so that is where we're in here. We're down to this point. Next, it says that we want to check line of sight, and it says, hey, collision manager, and it doesn't know right now what collision manager is. So we can include collision manager.h here in the agent.cpp. And it says our agent line of sight to endpoint, right? Which is something that we've already kind of calculated before, right? Is what we want to send in over here, because it goes from, so notice up here, the set middle line of sight endpoint, and it is the get transform position plus the direction times the thing. That's all the stuff that we could actually move this part, which is the stuff that we've kind of the agent get current direction, as an example, is the direction that we have, but we're doing it up here already, because we're saying set the middle line of sight endpoint to this to this already. And so we want to be able to check that instead of doing this calculation here, because we've already done this calculation up here. So we can remove this, is what I'm saying. And of course, then all we need to do here, instead of agent line of sight endpoint, is we can just do a get middle line of sight endpoint, which we've already done up here. We set the middle line of sight endpoint. We're just using it down here. So we're just refactoring a little bit to make it a little bit more a little realistic. Again, line of sight color for this one, and it says it really depends on if the target object is an agent, right? Target object. Then it is 0011, which is red, green, blue, right? So a blue line of sight color, or it's a red, green line of sight color. That's the line of sight color that we're doing. And we're changing the line of sight color here. Here, for this example, we're not going to do that. So we're just going to remove this has line of sight color from this part. And we're also going to remove the line of sight color value from here, because we don't need it anymore. So that's where that comes away. Also, here where it says set has line of sight, we don't want to do that in the if statement. We want to do it after the if statement, right here, just before we kind of pass it off the has line of sight. And I'll talk about that in a second. We don't have to set a line of sight color, because there's two functions, one to set the color, a manual color, and the other one that we can use to just set red or green, and that's what it's going to be. So that is what's happening there. Now these ones are green underlines, and green underlines tell us we can add const, and that's fine. So that's kind of just making it a little better. We're calculating stuff and adding const. Same thing with this one, has line of sight. We can rename it. It's telling us to rename it. I'm not going to rename that. That's pretty cool. Agent to line of sight distance is probably going to ask us to move it to an if init statement. I'm not going to do that here. So that is what this little function does. And I think we're pretty good in terms of getting things going. So that's the first piece we wanted to take care of, which is the check agent line of sight to target. Let's put this up on GitHub. So again, I'm going to go here, git add dot, git commit -m, and we're going to say added check agent line of sight to target and agents git push. Okay, so we did that part, and so now we've kind of done all of this. That's what we've done. All the agent.h stuff is finished, and now comes more of the timing stuff. Okay, so we have two enemies we're going to add in. We're not going to use Starship anymore. Okay, we want to make something a little bit more specific. Okay, so we're going to make two more agents. One of them that is called close combat enemy. Again, this is aligned with your assignment 4. And the other one that's called range combat enemy. We're going to start with close combat enemy. So again, let's go into our project. Here's our project. And where we want to add them is inside of the agents filter, so here. And the easiest way to get this done is to just copy our starship.cpp and our starship.h and rename stuff, because really at the end of the day, it's just the easiest way to do it. Later, we'll make some bigger changes so that it's different than the starship. Okay, so we can do it in two places. Now, if you notice, if I just right click and add them in, if I do a copy here, that's fine, but you don't know where they're going to paste it here inside of the in the project, and I always prefer to do it in the in our solution. So like actually in the when I look at it in online inside of the actual files. So here, if I go to the file system, there's 7.2, and if I go to the SRC folder, and we can go to the I'm just going to go to the Starship. There's the Starship right here, right? And I'm just going to copy Starship and paste it a couple of times. Okay, so I'm going to copy it. Actually, I'll copy it once for now. Copy it and paste it. And instead of it being Starship copy, of course, I'm just going to change this to close combat enemy. So it's going to be called close combat enemy.cpp. And same thing with the starship.h file, right? Because there's that different, the .h. I'm just going to change this to close combat enemy.h. Okay, so those are the two changes so far, close combat enemy .h and close combat enemy.cpp. And that's the first thing we're going to start with, just like it says here to do. All right, and now I need to include this inside of my project once I've copied them, and we need to make changes. So let's do that. So I'm going to go into the agents folder filter and add in an existing item, which is going to be the close combat enemy that we're adding in. So close combat enemy. Let's make sure we're looking at the right folder. There we go. So close combat enemy.h, close combat enemy.cpp. I'm kind of control clicking those and adding them in. You can see that they come in, but there's a problem because right now the close combat enemy is identical in every way, including its name, to Starship. We don't want that. We want to rename it to close combat enemy. So let's do that first. So first off, whenever there's anything that's named Starship, Control F, we can go and change that to close combat enemy, close combat enemy. Let's do that. So all those changed, and we'll replace all them. Okay. We also want to rejig this. This isn't right. It did it automatically, so it's going to be close combat enemy. It did that for me, which is not what I wanted, but hey, it's okay. It's only a minor discrepancy. So that's going to change, and I'm just going to copy paste those and this part right here. So those are the differences. Right now, everything is the same. And that's the first part for close combat enemy. I know I'm going to add decision trees in here. So let's add that in now. So include a decision tree.h to the close combat enemy because we're going to do that. Save. And then let's change my close combat enemy.cpp just to make it functional. So again, close combat enemy.cpp. Wonderful. And I'm just going to rename everything from Starship here to close combat enemy. So again, Control F. It's going to ask me to change everything. I'm not going to rename these ones right now, but they could also be named to close enemy in a second. So first, let's just make some changes. So that's what I want to change to, Starship to close combat enemy. And let's do the replacement. So we replace the first one. And you can see that, well, actually, let's just replace them all. And then we'll go and fix them because that's going to be just easier to do. So yeah. So that's first thing, we just replaced everything. Instead of this saying in the texture manager here saying close combat enemy, let's just call it close enemy. Doesn't have to be so crazy. And for the close enemy, instead of using an NCL small, remember I showed you a different texture. It's like a different kind of combat vessel. We're going to use something called a D7 small, which is inside of your files already. Okay. So that is the difference there. So yeah. It also gives us some things here, right? So we set up things like acceleration and, which is here. It gives us our maximum speed, right, as an example, which is 20, as well as the turn rate, which is 5. All those things are up here. It also instantiates our default position so far. That's what we've been doing. And the default position up here that we have is 300 and 500. But we're going to reset this. So let's, just for now, I'm just looking at my notes. Just for now, I don't think we need it. So let's just remove our start position. We won't set up our start position at all, right? Because what we'll do is we'll kind of adjust certain things here for this, right? So that is what we're going to put in there. So no start position setup, okay? Let's go through it just to make sure that everything is as it's supposed to be. Yes, that's good. Set width and height. We're casting for X and Y. So again, we have our position, our velocity, our acceleration, and is colliding. We're not going to set up this position right here. We're going to set it up somewhere else. So we can remove that. Our current heading, our set line of sight distance, and all those things we need to set. So current heading should be 0, and line of sight distance here should be 400. That is correct. Whisker angle, we're not really using, but it's in there right now. And set current direction is also something that we want to do. So set current heading is 0. And a lot of times we also want to set current direction so that it's facing right. So we'll say that. So we'll say set current direction so that it's facing right, which is a new GLM Vec2 object with the new direction, which is going to be right. Right, so this is facing right, okay? Line of sight distance, max speed, all those things is good. Set line of sight color to the right color. Set up our agent, the type of object to an agent, that's good. As well as, and what we did for Lab 7 last week was we set up our action state to start off as no action. And then we built a patrol path around the screen. This is the same. Okay, this is the same. So that is something we're just adjusting for our agent. And again, when we're drawing, make sure we draw our close enemy. That was changed. Let's just go and make sure that is changed as well. So we're drawing our enemy at its position and in the current heading, moving in. And again, here it's when we say 255, if you look at the drawing, 255 is the alpha transparency value. And is it centered? I think the answer is true, right? So centered is true. And then we don't include render flip. Render flip allows us to flip the object so it looks the other way. We don't need that. So when we, that's drawing the ship. And drawing the line of sight, we only want to do this now, the draw the line of sight stuff, only if the IM GUI is active. And I've kind of provided a little function for you to do that. So we're going to say if, here's how we're going to do that. Hey, event manager, I want to go through the instance methods. Let's include the event manager singleton. I want to go through the instance method, and I want to say, is IMGUI active? If IMGUI is active, that means that IMGUI window is up. Then I want to, only then do I want to draw my line of sight. And let's just copy that and put it there, okay? Sorry, so Vander had a question. It says, what was the new include in the close combat enemy.h? The only thing I added in, Vander, was the decision tree.h, just to make sure we're starting with that. All right, let's just make sure this is correct. So we're drawing a line from the position plus our current direction times 0.5. This gives us so that the line doesn't start exactly on top of our enemy. It starts outside of the enemy times the width of the ship. And then the distance, of course, that we're drawing is we're making a calculation here. And one great thing, because we already set up the get middle uh, line of sight endpoint, we can use that instead. So we can say get middle line of sight endpoint, and that middle line of sight endpoint is something that we can do because that's being set by our agent, not necessarily here inside of our close combat enemy.cpp. Yes, that's what that is. Okay, so those are the changes to our draw function. Our update function also is going to change, right? Because right now it's deciding whether to go do patrol or move to line of sight or attack. For now, let's just cut this all out. We don't need it because that doesn't make any sense right now. We're going to come back to this. Clean function is going to stay the same. I'm just going to go through some of the stuff that's in here. When we get back to set max speed, we have get max speed and set max speed. One thing we could do we could mark these as const. So we can do that. We didn't do that last time. It wasn't important, but we're going to do it now. Set turn rate and all that stuff to modify our agent a little bit. Set desired velocity and set acceleration rate and all those kind of things. Those can remain the same. There's no difference there. Seek function is still going to use the waypoint calculator to move around the scene. This is what we did last week, where we found the waypoint if we're within 10 pixels. We haven't changed that. Look where you're going function is staying the same. Build patrol path is going to stay the same. And so that's part. Move is pretty much going to be the same, as an example. And then there's check bounds as well as a reset method. That's pretty much everything as is. We haven't changed anything so far. Great. So that is the initial changes to the close combat enemy. We haven't made many changes yet. What we do want to do, right, for sure, is we definitely want to add that in the .h. Let's go back to the .h now. And I want to add a reference to we want to add a reference to build tree and the decision tree. So way at the bottom here, after move and check bounds and all that stuff, right? We can go in here and we can add, so new for lab 7 part 2, we're going to add stuff. We're going to add the decision tree pointer, which we're going to call m_tree. And we're also going to add a new function called m_, and again, it's build, just like we did before, build tree. There's our build tree function that we're going to actually define. Sorry, not here. We're going to define it inside of our, the build tree function inside of our CPP. So this is where we're going to do the decision tree, okay? So that's one thing we need. We also have several functions, right, that we want to add in, right? And because close combat enemy is a agent, it has an is-a relationship with agent, right? We want to add in those, we want to override those functions. So here inside of the public area here, again, this is new for lab 7 part 2. We want to do a couple of things that are different. We want to override the patrol function, because patrol is part of all agents now. And we want to void override the move to player function. That's also part of all agents, right? And we also want to have a function to return the decision tree. I want to be able to get the reference to the decision tree outside of, why is it const? It shouldn't be const. Let's just get rid of const. It should be a, we want to return a decision tree, right? And the decision tree itself is the thing that we're going to return outside of the function. So outside of our agent. So if I want to get a reference to the decision tree, let's say in the play scene, I can do that, okay? And I can do that right here, because this decision tree is going to be unique to the agent, right? Every agent's going to have its own brain, and this is what this decision tree is. Okay, so that's kind of the changes we made. And of course, what I want to do here is we want to in kind of define some of these functions that we've made. So again, I'm just going to go to the top of the class, and I'm just going to use ReSharper here to do that. So I'm going to say generate definitions by declarations. And there are going to be these new definitions, the patrol, move to player, get tree, and m_build tree. These are the definition stubs for my close combat enemy, and I'm going to click finish. It's going to put those into place here at the bottom of the class in the CPP file. Let's do that now. Let's go there and fix them up and put in some of those functions. We'll start off with, again, just to show you what we've added patrol and we've added move to player, okay? So what does patrol look like and what does move to player look like? So first we'll start with patrol. So patrol, again, is going to be if, let's get our action state. Whatever the action state that I set up is, normally by now it's no action, right? That's what the action state starts off. If it's not equal already to patrol, that's what we're saying here, then what I want to do is I want to initialize the patrol action. So I'm going to say set action state to patrol. Okay, that's what we're going to do. So patrol, the actual patrol method, that's all it does. Okay, pretty simple, straightforward. And the same thing goes with the move to player action. So it's identical to this. So we're going to say again, if our get action state, right, is not equal already to our action state, move to player, this one, then we want to set our action state, this one, to our action state move to player. So why am I doing these checks? These are little checks so that way it doesn't spam in the console, that we're just going to keep on kind of setting it. If it's already set, then it's just going to skip over this, and it's not going to try and reset our action state every single time. It's only going to set it once. Okay, so that's what this is going to do. So those are the two. And notice we don't have a attack action here. I'm leaving that out for today because we don't need to do that. But patrol, move to player, and then attack. Move to line of sight also could be another one that we can put in here. We don't have that action here, move to line of sight action, but we certainly could. Okay. But the reason why we're doing that is because patrol will do that for us, because patrol will be able to move to a place where, oh, there, I spotted the player, and then we can go from there. Okay, so that is the two things here. Get tree, I mean, that's pretty straightforward. All we're going to do is going to return a reference to the tree. Okay, so that's done. And now the build tree method. Okay, so close combat enemy, I mean, it's very similar to what we already had in the playscene.cpp. Let's go there. Playscene.cpp already had a, was it playscene.cpp? Sorry, decision tree, decision_tree.cpp. For all decision trees.cpp, we had this build tree method. I'm just going to copy everything here, right? So these are all the things we did in the build tree. And I'm just going to, in the decision tree.cpp, I'm just going to copy them and go back into the build tree method here and post them in. And I'm just going to uncomment everything one step. Oops. There we go. And now you can see that we're going to get some issues, right? We're going to get some issues. And we're going to talk about these things and how they work and what do we need to do and what do we not need to do and so on. So, yeah. So remember that some of this is going to change now because of all the things that we need to do. It's also asking me to add stuff in because it doesn't recognize here in the what is a patrol action, what is a move to line of sight action, what is a move to player action. It doesn't know these things because we never added in the includes. So let's add in patrol action. There we go. Move to line of sight action. I'm just going to use the our little hinting here to do that. Move to player and attack action. Those are the things that it would be able to do now. Cool. And here, instead of the way we did this part, because this was done so that the decision tree itself would have a new line of sight condition, that won't work anymore. What we want to do is we want to set the line of sight node for the tree that we're building, this tree right here. So how this would look is different. We would say something like M underscore tree, right? And we're going to set, so here's what we need to do. We need to set the line of sight node, right? So set the line of sight node. Now, tree itself, just to notice, right? Right now, all it has is set agent. And what we want to do here is we want to be able to set the line of sight node and all that kind of stuff, set the radius node, set the close combat node, that's built into the tree itself. So notice here, if I go back to here, it says that include decision tree.h, add public methods for the new actions, patrol and move to player, add a getter for the tree, add a private decision tree pointer, and a familiar build tree method. And then in the CPP add includes for the tree, right? And change the texture to be D7. We did that, ramming speed. In the draw only, draw line of sight. And if you haven't filled in the bodies yet, we can fill them in for build tree. We're going to do this in a second, but what we need to do is I want to be able to set my line of sight condition, my line of sight node and everything else in the tree. And trees right now don't have that capability. So let's get back to this, undo. This is what the original code was, right? And we're going to get back to this in a second. Here, let's just pick some of these things, right? So tree add node, we can still do this, M underscore tree add node, that computes, right? So this is okay. So we'll change all these add nodes to tree add nodes, right? So we're going to do that for now, okay? And tree list, there's no tree list, but actually it's the tree. So we're going to say, so M underscore tree, right? And then we're going to get tree. So notice that the tree itself, right? What we need to do is we also have to be able to return a reference to the tree, right? So again, there's some other things we need to modify in the tree itself. Let's just go back and I'll put that back into play here and here. So a couple of changes we need to make, sorry, before I move on, but those are okay. So I've just modified what I can to make things work. How about agent? Well, agent, it points to this agent, the close combat enemy. So we can just say anything where you see agent, that's this, because this is an agent. So we can replace those right now. Okay, so notice I'm just making changes here so you can see how that is. Okay. So kind of straightforward replacements there. Now there's still some stuff here. Add node, again, that would be tree add node, M underscore tree add node. So that we can fix. So we add node something and there. I'm trying to fix as many of the errors as I can before we make some more changes, right? Because there's still some stuff here that we can't do because we haven't enabled this stuff in the tree structure. So let's hook back to decision tree for a second. Okay. Let's go back to the decision tree for a second to talk about this. So if I go back to decision tree.h, right now what we can do is we can get line of sight node, get radius node. We can do those things, right? Get radius node, get line of sight node. And this is inside of our public space, get close combat node. We can do those getters, okay? We've done those things. But we really don't have any way of setting it. In the last thing we did when we built the decision tree, we never built any setters for set radius node, set close combat node, and all that kind of stuff. We didn't need them, right? This time we're going to do that. And right now we only have get line of sight node, get radius node, get close combat node. We also want to get range combat node. We want that as well. And also a get tree function. So we have to modify our decision tree.h to do that. So let's do that now. So again, I'm just going to return a, and by the way, for the getters, we have a close combat condition. We have our agent. There's our get agent and our set agent. We have those two things. right? But notice we only had getters, which means it's just read only at this point, right? So we want to modify what we have so we have more stuff. One thing we need is the get close, instead of get close combat node, we also need the ranged combat node because our decision tree could have both. So ranged combat condition is what we want, ranged combat condition pointer, and it's going to say, hey, the ranged combat condition is undefined. There is no ranged combat condition because if I want to return ranged combat condition, we would need a ranged combat condition in our conditions. So there's nothing like that. Eventually, we're going to have this for our ranged combat enemy. So this is something that it's going to look like. I'm just going to comment this out for now, but I want you to type it in. So ranged combat condition, right, is what it's going to return, and it's going to be called get ranged combat node. We don't have this yet, but we will. And it's going to be a const pointer. We're going to uncomment this out later on. Next, we also want to get a vector, a reference to the tree itself, because remember that the decision tree, it has a tree structure down here, which is our tree node list. And unless we share the tree node list so that I can access it from outside of this, the decision tree class, then it's stuck in here as a private member. So we're going to make a getter for this too. So we're going to say, we're going to return a standard vector of type tree node pointer, and it's going to be a reference that we're going to return, right? A reference to this when we call get tree. So that's what get tree is going to do. All right, so that is the new functions for this one. So we can get line of sight and all this kind of stuff. We don't have setters for this yet, and we do have this get tree. So what we want to do is we also want to have setters. So again, we'll say new for lab 7 part 2. We're going to add the setters in now. So we're going to say void. If I want to, we already have set agent that we have, but we don't have our set line of sight node, set radius node, set close combat node, set range combat node. We don't have any of this stuff, right? So we're going to do that now. So we're going to say void set line of sight node, and the line of sight node is going to be with the line of sight condition pointer that we're going to pass in, which is the node that we want. Okay. We also want to set the radius node, right? And it's the radius condition pointer, which is the node that we're going to set up. So this is the ability for us to set it remotely, like outside of this class. Before we didn't need to do that. And then next, we're going to set the close combat node, and it's going to be the close combat condition and the node. And then finally, not now, but we're going to comment this out. Let's just comment it out. We're going to set the range combat, since we're here, it's range combat node, which is going to be the range combat condition, which we don't have yet. We haven't made that yet, range combat condition. And it's going to be a node. So those are the things we're going to add in. Those are the setters. The rest, add node, which is good. Display, update, and clean, and make decision is okay. Agent, line of sight condition, radius condition, close combat condition, those are good. But new for lab 7 part 2, we also need to add in the range combat condition, which we haven't made yet. So again, let's just comment this out. It's going to be called the range combat condition pointer, which is M underscore ranged combat node. Okay, so that's something we're going to add in. Look, we're going to add that in later, but I'm putting it in here. I'm penciling it in, kind of thing, so that way I know this is something we're going to add in. Save. Okay, so that's kind of some changes we made to the decision tree.h. Okay, in order for us to facilitate getting, kind of getting this stuff done. So I'm going to go up to decision tree. I'm going to go to the little hammer, and I'm going to say generate definitions by declarations. And I want to generate get tree, set line of sight node, set radius node, and set close combat node here, and click finish. That will add those functions in here. And now in the decision tree.cpp, we want to make those functions changed. So again, I want to set the line of sight node. So that's just going to equal to M underscore line of sight node is equal to node, right? Is equal to node. And that is where it's going to be here for, for our get tree. I forgot that one. Return M underscore tree node list. So that's what's going to be returned. So that way we can access our tree node list outside of here. And then the set radius node M underscore radius node, that's going to equal to the node, whatever that is, right? And finally, the set close combat node M underscore, again, the close combat node is going to equal to node. So this is just setting up those things from outside of the class. Set agent, no problem. We can do that up here. We allow you to do that stuff, so that's good. And everything else is as is it should be. So no changes so far in terms of how things are going to be. Okay. Excellent. So again, all this is good. I don't see any other changes that I'm looking at right now. We may, when it comes to making a decision, remember we had a make decision, to traverse the tree in order, and that was this part. So this make decision function is still good, and so is the clean and everything else. So this is just starting off at 0 and checking if it's a leaf, and then we're using a ternary operator to decide which decision to make based on where we are. So that is everything for the tree update that we have to make. So tree is done. Now, once we've updated the tree so that we have setters, we didn't have them before, we can close off the tree.h and tree.cpp and now start modifying the close combat enemy again. Back to the close combat enemy. Okay, so here what we want to do is we're going to say that we have a line of sight node that we're going to store in the decision tree. Each decision tree has the ability for us to store this now. And I can say something like M underscore tree, and then we want to set our line of sight node, and we want to set it to this new anonymous line of sight condition. That's what this is going to do. Tree node list, we don't have direct access anymore, but we can say M underscore tree, get list or get tree, and we're going to push back this, kind of line of sight node. And the way that's going to be is M underscore tree, and then get line of sight node that we're going to push back. So that's the difference. Notice that that red stuff goes away. Next, radius node, same thing. So we're going to say M underscore tree, set radius node, and that's going to equal to this new anonymous radius condition that we're setting up. And here, line of sight node is going to be the parent, right? Because remember what happens is add node says, tell me what the parent is, tell me what my left child node is, or my child node is, and the type, okay? So what is the child node, what is it? So again, it's going to be the parent for this one is get line of sight node. So M underscore tree, get line of sight node, that's the parent. And for the radius node, let's just get the radius node, M underscore tree, get radius node. So here we're being more abstract because we're saving this information in the tree structure itself as opposed to embedding it inside of the agent. Okay, so the agent's not holding the tree information directly, it's holding it, it's created a tree structure and we're holding it in there. And again, just like before, we want to use this get tree methodology to push back the radius node, which is this one right here. Okay, so that is fixing some of those problems. So you see what I'm doing? Any questions so far when I'm doing this refactoring? All I'm doing is I'm moving the tree structure, the build tree structure, I'm moving it inside of the close combat enemy, as opposed to having it directly in the decision tree, because that makes every enemy the exact same if it was in the decision tree. If I build the tree inside of each enemy, then each enemy is unique, but I can make many enemies, right, as opposed to one. All right, so let's continue. So set close combat node is here, so we're going to say M underscore tree, and we're going to set close combat node to this new anonymous node. There we go. And again, we're going to say M underscore tree. And this one is going to be the get line of sight node. that's going to be that one. Line of sight node is going to be the parent. And close combat node, M underscore tree, get close combat node, that's going to be that one. We're going to take the tree list here. You probably can do it faster than me now that I've shown you what to do. And we're just going to grab this part here and put it there. So nothing has changed so far. What we're doing is we're just restructuring or refactoring so that way we can build the tree here as opposed to where we had it before. All right, so this part, tree node and radius node, M underscore tree. Again, it's going to be get radius node. That's just going to be a reference. And here we're just going to change the get tree function. Let's just do that for a bunch of them so it doesn't make me crazy, like so. Okay, so that fixed those ones. Get radius node is this one. So again, it's M tree get radius node. And this one is get close combat node, which is, I just can copy from here. Good. Everything else is the exact same as we had. So again, patrol action, move to line of sight action, move to player action, move attack action, and so on. All the same things that we had before, but now it's embedded inside the build tree as opposed to everywhere else. Okay, I'm just going to make a check. Are you with me? Check mark if you're with me, X if you're not with me. Okay, got some Marco's good. Jaden, Ali. How about Vander? Are you good? You get's good. Yeah, you're good. And Kieran, how about Kayla? I got a couple people here, Fabian and Abu. Hopefully you're all good. All right. So I'm checking because, again, you really can't do the build tree method without it. So this is the build tree, and we can actually almost test our function with this right now, right? So let's go back to our instructions. So again, we we win the starship, we change the close combat enemy, we include decision tree, add public methods, add a getter for the tree, add private decision pointers, and made some bunch of changes here. In the draw, only draw line of sight. If you haven't filled in the bodies yet, blah, blah, blah. We're not doing the range combat enemy yet. We're going to come back to this. What I'm going to do is I'm going to test the close combat enemy here first, and then come back and we're going to get this done, okay? So that's what we're going to do next. So what I want to do is I want to put this up on GitHub here at this point because the close combat enemy is done. So we're going to say here, clear, git add dot, git commit minus M, and we're going to say added close combat enemy. Guess what we did? Git push. So those are the two things we kind of added in, and I'm going to test it now in the play scene. So we'll set up the play scene now, and then we'll come back and make the range combat enemy after, okay? So we can test what we have. We can't really test it yet because, well, there's nothing to test. It's just a starship, right? So going back to here, I want to go back into the playscene.h, and so far the playscene.h, it needs some changes. You know, at the top we have background, we have obstacle, scene, path node, and we have target and line of sight mode. Those are all the things we have up here. But we need to add in the close combat enemy. So let's add that in there. Include the close combat enemy. .h, there it is, close combat enemy. Starship, what I'm going to do is I'm going to comment it out, or I'm just going to remove it. So we don't need the starship anymore, which is going to cause errors that we want. We want these errors. The starship should be removed, right? And instead of the starship, right, we don't want the starship to be put in there. Let's get rid of it. Instead of the starship, what we want instead is underneath the target, we want to add in the close combat enemy. Here it is, close combat enemy, which is a pointer that we're going to call the starship, M underscore P starship. So what I've done is just replace the starship with a starship type, and I've just named it I just renamed it to the close combat enemy. All right. So what we're going to do is when we want the ranged combat enemy, we'll just go something like, you know, ranged combat enemy pointer. So put this in, please. And this should say the same thing, M underscore P starship. So that way we can swap out one for the other for testing purposes only. This is new for Lab 7 Part 2. I'm putting these in there so you can see where the changes are in each of the files. Okay, so this is definitely something we need to do. All right. All the rest so far is the same. Line of sight mode and clear. We've removed the decision tree references, and that's really great. So let's see what we can do to put in the starship in place and make some changes to the placing to test it out. Okay, a starship being the close combat enemy. Let's go to the CPP file. So CPP, all right, so here is M_P starship is being called, and it's notice that it says in the GUI function, it says that we're casting the M_P starship should actually compute now. Hold on a second. Did I make a mistake? Orema placing.h M_P starship. Huh. Let me just save all of this stuff here so that we don't have anything that's in here, because this should actually be M_P starship should be there. P starship, there it is. Yeah, it is there. It's just Visual Studio being Visual Studio. Oh, okay, that's good actually. That way I made it starship instead of starship. It's okay. Thank you, vendor. I'm just going to replace it so that way these are all the same. I just want to make sure that okay, so this is good. But now this is wrong. So this won't be a new starship because the placing, that's one change we're gonna have to make every single time. When we look at the placing.cpp, then one of the changes we're gonna have to make is inside of the start method all the time. So whenever we set up a new starship, M_P starship, this one, it can't be a new starship anymore. It's going to be a new, in our case, a close combat enemy. So that's what the starship is going to be. So this is going to be close combat enemy, right? And we'll just replace that with starship. That's just me, my bad, right? So there we go. Just named it differently. All right, so that is that's the one change we're making there. And there's so far some difference up here. Let's fix that problem here inside of the update function. That's the update function. Let's go to that update function and fix it. And so in the update function, right now we're going to say, so let's check. It says check line of sight, M_agent, check line of sight, right? With our starship. Do we want to do this? We want to do this, check line of sight with the starship, right? Well, the answer is no, we don't. So this is no good anymore, right? Because we don't want to do that check agent line of sight here. In fact, what we want to do instead is we want to set we're going to say M_P starship, and we want to get the tree from the starship because the starship now has its own tree, and we're going to get the line of sight node. I'm going to set a line of sight condition of the line of sight node to our M_P starship, and we'll put this on 2 lines. Check line of sight to target, where we take the M_P starship and the M_P target, as well as the M_P obstacles, and we're going to use all that for everything. That's kind of on one line. So that is the difference. So starship, instead of it doing what we did before, it's going to check, kind of the line of sight with that. Okay. Next, when we do our switcheroonie here, our switch case, we have before we had our target, ship, and both. That is still going to remain the same. This just needs to be renamed to M_P starship. There we go. So I just named it differently. And there's only one other place we have to fix, which is here, M_P starship, M_P starship, which we didn't change. So that should do it. That should kind of enable everything, all the functionality. One other thing that I want to do is I want to change the music and the and all that kind of stuff as well. So just to show that we've done some changes, I'm just going to go back into the start method. Just going to jump there now. Let's do that. Start. And in the start method, we'll change this to Lab 7 Part 2 so we know which one we're at. The background's the same. All that stuff is the same. But the music has changed. So let's change the music. So the A sound is cool. Where it says Mutara, we can keep it if you like, but I like to change it to the one. It's going to be called Klingon, which is what it is. We'll call this Klingon. By the way, this should be already in your assets. And to check this, if you look up, if you go to Assets Audio, you can see that we have Klingon in there. Klingon dot with a K, capital K. And by the way, if you spell it wrong like this, it doesn't matter, because remember that whether you spell it capital K or lowercase k, it doesn't matter, because it's going to play regardless, because Windows doesn't care. Should we call build tree and constructor of the close combat enemy? Let me make sure, because that's something that I want to check. So Klingon. So let's go back to that close combat enemy under agents, close combat enemy, and we're going to look in the constructor function. And let's take a look here in my notes. Maybe I missed that part. And if we did, this is why we're testing, right? So if we're testing and if something is wrong, then yeah, for sure we would have to do that. So new for lab 7 is this: set target, set action state, and build patrol path. We kind of did that, right? But we need to create the decision tree, which I haven't done there. So yes, you are very correct. So here, new for lab 7 part 2, we forgot to do this. I did. M underscore tree, we need to build it. That's going to equal to a new decision tree, okay? And I'm going to pass in this as the agent. So this is, create a new tree. And then we're going to build it. Here's our build tree function. And we're also going to display it for the first time. Display. Okay. So this is, again, optional. We don't really need to do this, but I'm doing it because I want to do that. Okay, this is I'm displaying the tree here. And remember, in the update function is also something we have to update. So in the update function, we need to make a decision. So this is, kind of, let's determine which action, well, which action to perform. We have to do that too. So that's going to be M underscore tree, and we need to make decision. Okay, that's what we have to do there. So that's going to happen in its update function. And we didn't do that. And of course, that's my bad, because, without this, then the close combat enemy wouldn't be working. Save. Okay, so now that we've made all those changes, let's see if this is going to work by pressing play. And if it doesn't work, we're going to get errors and we're going to fix them. Pretty straightforward. So close enemy is going to be drawn. We've called it close enemy in the texture manager, and here it's going to draw close enemy as well. So in the draw function, and so it's running. That's good. That's a good sign. Okay, this is good. This is good, right? But it says performing patrol action, and yet it's not performing any patrol action whatsoever, right? So, but we're getting better. It does show us this, right? And it should move our ship closer. So if I press the toggle, you can see that those things are kind of are done. It changed this up to so it doesn't error out right now, but it's not patrolling either, right? So it's not patrolling. And so why is it not patrolling? Let's run this one more time. So remember what it's supposed to do, right? It's supposed to look through, and if it doesn't have line of sight, right, then it's supposed to, it says performing patrol action. But the problem is it's actually not doing the patrol action. So remember what we did to make the patrol action function is in the close combat enemy itself, it needs to actually do the patrol action. And, so the close combat enemy has a build patrol path, but remember how it does the patrol action, right? It's going to make a decision. So the make decision method, which is something that we need to do, right? Depending on what it's going to do, it's going to either patrol or not. Okay, that's what's happening here. So we start off with no action. That's the action state for the close combat enemy. Then it makes the decision tree, which is good. It builds the tree, and then it displays the initial tree. Okay, that's what it does. In the update function, it makes a decision. So whatever the decision is going to be made, it's made. Okay, so that's what it does. And then down in here, it's got to seek to the target, right, as an example. And if you look further down in the patrol action, if I go back all the way to the patrol action, here's the patrol action, right? And here's the move to player action. So if the patrol action is activated, then we're going to set the action state to patrol. Okay, set action state to patrol. And then, well, remember in the move function, what we're doing is we are seeking. So depending on what the seek is going to do. So that seeking is going to, I'm just tracing it for you. So you see that it's not quite working how it's supposed to. So this is the tree, right? And what is the seek action? What does that look like? So here's seek, and it says, if I'm doing the patrol action, right, then how is seek going to work? Well, it says if my utility distance get transform position is less than 10, then da-da-da-da, right? That's kind of stuff that we want to set up. Waypoint and set target position, all that stuff. So that's what it's telling us to do. And it sets the desired velocity to the get target position and all that kind of stuff. So get target position and get current direction and steering direction, all that stuff is going to come from the stuff that we set up in the target, whatever the target is. Here, it's setting up the target. It's basically saying, set the target position to the next point in the patrol path, right? So that's all the stuff that we've already done and everything else. So what is the problem? Why is it not moving? Because it's not patrolling, then we're kind of, it's not exactly working as it should. So can you tell me, do a little bit of troubleshooting and try and see why it's not moving? So here's the draw function. The draw function basically says it's working because this is exactly what it's doing. It's actually drawing it up. Let's take a look here again inside of here. Okay, so this is somewhere where I would look. So max speed, we set that up. We set the current direction. We set the current heading. We set the line of sight distance. We set the line of sight distance. We set the whisker angle, which we don't need, right, as an example. In fact, if you really want to, for the whisker angle, if you don't want to set that, let's just clean it up. So we don't need this. Set a line of sight color. Setting a line of sight color to red. That's the default color, right? That's good. Set line of sight distance. Those things are done right. So direction, heading, and direction, and all that stuff is all good. Velocity is set to 0. Acceleration is set to 0. Is colliding is set to false, right? These are all good things, right? So, but it's not moving, right? Where before it was moving. So what is the reason why that it's not moving? Here's our build tree. Here's our build patrol path. Go to definition. Our patrol path looks like the first node in the patrol path is 76040, and we set the target position to the waypoint. Okay, so that is something we're doing. And the waypoint, right, is if you scroll up to the constructor function, where is the waypoint set? Because waypoint has got to be set somewhere to 0, right? And that is something that we should also consider that needs to be done. So waypoint. There is no action state switch in the update function. Okay. So in the update function, here's the update function, right? And in the update function, right, which we have in the close combat enemy, right, it says make decision. Well, let's go to that make decision thing. What does make decision do? it says, if I was to go to make decision, so that's where it should be done. That's the update, right? Make decision basically says, let's take a look at the tree node list, right? That's what that is. And the tree node list starts with the root node, and depending on where it is, go through the list. So this actually does something. And then it says dynamic cast, go to the action. So what do you mean by that? And it doesn't call the move in update, but where should move be called? Right? Because move is going to be called somewhere, right? Move is something that needs to be done for the close combat enemy to actually do the patrol, right? That's something that needs to be done, right? So what's missing? What's missing? Because at the end of the day, right, this is the exact same as all the other stuff we have. So where could we update this to make sure that everything moves? Because we're going to copy this in a second, and if it doesn't move, it doesn't work here, it's not going to work for our ranged combat enemy. Could it be in the placing that we didn't do something? Right? Because in the placing, let's go to placing.cpp, and let's just start at the top. Starting from the top, again, here's the draw function that draws everything. So that's not really the problem. We're just drawing the display list, right? And then in the update function, here's the update function. That so one thing we're saying here is, here's the decision. We're saying, okay, if the Starship line of sight node, and we're setting the line of sight, get line of sight node, and then we're setting the line of sight from the Starship, and we're checking agent line of sight to target from the line of sight, as an example, of the Starship to the target and the obstacles. And that's what's setting the line of sight, if we have line of sight or not, in the tree. And switching, if we have line of sight, then from a line of sight mode perspective, we can decide this is something for I am GUI. Okay, so this is the piece we had. We had the make decision down here, but now make decision is going to happen in the actual the display list. The display list itself is going to call the make decision method from the Starship, because the Starship is part of the display list. So that is not something that's changed. So where else? What else is possible that's happening? That's not thinking, because we need to do that. So in the close combat enemy update, okay, but in the close combat enemy update, as an example, so think about this, right? I want to call the move function and I want to seek, right? So that's what I want to do, right? But then, but do we need to do it there is what I'm saying, right? Because, and the reason why I'm asking you is because we're troubleshooting what it should do compared to what it actually is doing. Okay, so what it should do, so there's our toggle grid, and agent line of sight is what we had. We really don't need this agent line of sight anymore. Remember, agent line of sight is something we replaced. We can probably comment this whole piece out. Check path the line of sight is good. All this stuff is good. And clear nodes. And here's our start method. Let's go back to that start method again, that pesky start method. And let's see if there's anything in there that needs to be done. So again, we set the placing, line of sight mode. We made a new target, right? So that's the new target object. We built the obstacle pool, which is what we did. We made the Starship. So that's the Starship up here. And we set its position to 40 and 4, and we set this up. So this is when we set the Starship up. Everything else is identical. So where are we ever going to call the move function? Right? Because let's see what the Starship did, the original one. We never changed anything here. Let's go back to the starship.cpp and see what the difference is. So if I go to, just to your point, if I go to the update function here, it says that we want to do patrol, move to line of sight, or attack. This is in the update function, okay? That's the action state that we'd had before. We said, okay, depending on what we're going to do, whatever the update is, right, that is what we're going to do. The action state's going to be set up, and this is what we want to kind of have into place. But right now, our update function does not do this, right? Our update function instead of doing this piece, right? All it does is do this piece, make a decision. That's what's in the update itself. So that's not going to move us anywhere. I mean, if we're going to make decisions, right? So is it possible that we missed something? Is my question, right? Because without this piece, and this is good that you saw it as well. Without this, remember, we can't move unless we tell everything to move. So there's got to be some place where the move function is called in order for me to do the move at all. Okay, that's how it's going to be. Whether we're moving in the patrol or we're doing it somewhere else, somewhere the move function needs to be called. Okay. And in the make decision, right, in the make decision method, right, of the tree, so go back to that, go to definition, all it does is skim down and decide what to do. But in the decision tree, it doesn't really tell us what to do, right? So, by the way, decision tree, remember, also has an update function. And the update function right now doesn't do anything. Take a look at that, right? And maybe, I'm just putting it out there, that maybe in the decision tree's update function, because remember the update function of the decision tree, could it be in here that we're doing it? And the answer is probably not. We can do something in the placing if we really wanted to, but it's not there. So where else? Let's do what you're saying you get. Let's copy the stuff that we had from our starship.cpp here. And let's, depending on the action state that we're in, let's switch it and do that. Let's grab this part here from the starship. And all we have is patrol, move to line of sight, and attack. Okay, so we don't have that right now. So let's grab this and put that inside of the close combat enemy because that's the one we're making. And we'll do that here in this piece, right? So this is what you're saying to do. Okay. Here's the get action state and whatever. And let's see now if it makes a difference. Should we do it here is the question, though, right? Because here we have the action state patrol, action state whatever, and whatever. Now here it will do it. Okay, we'll see it. But what it's going to do is exactly what it's supposed to do, which is as soon as it sees the ship, it will stop. Okay. So what about inside the action node? Okay, I like that. So that definitely we can put it in here, right? But what about in the action node itself? So if I go into the patrol action, patrol.cpp, here's the patrol .cpc, that's the action. Are you saying in this node? In the patrol action? What do you mean in the action node? Right. So let's think about this for a second, right? Because we want to put this in the right spot, right? So here it says, okay, get action state patrol, and then what we want to do is what it says: get set action, right? Get set action state, right? Get agent set action state to patrol. So that's the action state that we're going to set, right? If this is not already patrol, set it to patrol. But we never did anything to make it patrol. So here inside the action node, this is a great place to do it. We can say, hey, agent, whoever you are, instead of being specific and having our switch case there, let's put it in here and we can say patrol, all right? So that is what we want to do, patrol. Go to definition. Go to definition for patrol. Patrol is going to be, remember, overridden. So if I go back to the close combat enemy and look at my patrol method, if I scroll down there, then that is where we should be doing the patrol inside of the patrol method, right? So if I skip down there, let's go to patrol, and this is way better if we did it this way. Sure, we set the action state to patrol, but what we want to do here at the end of this is go something like m_move. Right? This is what we want. We want to move our object here inside the close combat enemy. Move. Right? This one. Because if we don't call it here, if we don't call move in here at all, then how are we going to move if we're setting to patrol? This is better. This is better. So that way we go to we can go to the update function, and we don't need to do this. It's going to be based on whatever the state is that we set. So the actual action node itself is going to cause us to do the patrolling, which makes more sense. Could we do it this way? Could we have put it inside the update? Sure, we could. But why if the decision's doing it for us? We're kind of duplicating our work this way. Save. Good for you. So now let's see if it works. Now let's see if it works. Remember, getting it to work is 90% of what we want to get done here. Right now we're almost done. We're just going to make so here it works again. And we can see that until we have line of sight, it'll keep patrolling. And now it'll do the same thing that we did before. I can move the target position somewhere else, and it's going to patrol around the grid until it has both line of sight and is within distance. Okay, take a look at that. So still, even though it might have line of sight in some of these other spots, it's too far. Now it's close, but it still doesn't have line of sight. But as soon as it gets to a point where it does have line of sight, right, then, and distance, there we go, line of sight and distance, then it'll stop. And that's what your thing to do. This is great. We've tested out everything. Let's put this up on GitHub. Git commit add dot git commit -m. We'll say tested close combat enemy. Git push. Make sense? All right, so now that we've done the close combat enemy, all we're left with, we kind of skipped ahead. We kind of did all of this. And now take a look at this. It says, we actually said it here, action nodes, modify the action methods and all the action nodes with an if check. And this is the thing that we needed to do. We kind of did it in one because we did all of this right here. And what we want to do is we want to copy the range combat enemy to do this. And we also need to make a move to range action is what we need to do. Let's do that quickly before we run out of, we've already kind of run out of time. We're going to go a little bit over time today, but bear with me as we're going to do it in one. Okay, so let's do this now. We kind of prepared for this already. So again, going back to our assets inside of our SRC folder, we know we're going to make a new action, right? Or a new, so we have a move to player action. Let's go back and review, okay? We have but we need a move to range action, and we also need a range combat condition. Those two things we're also going to need. So a range combat condition, and we also need some kind of, we also need a ranged combat action, right? Which is what we need, right? So let's do that. So remember that when we were putting things together, as an example, and we were building up the decision tree.cp.h. Remember the decision tree.h? Let's go back to that for a second, just to show you. So again, in core, we have decision tree.h, and we said we had this stuff, this ranged combat condition. The ranged combat condition is something we need to put in place. So this is the first thing we want to do. Let's do that. So again, going back to our code or our files, we're looking for any condition like the close combat condition, and we're just copy pasting. And now let's rename. So we'll rename the close combat condition to the ranged combat condition. Ranged combat condition. And the same thing goes for this one, ranged combat condition. So making a couple of changes here. And at the same time, now that we've made a ranged combat condition, we have a move to player action, but it'd be nice if we had a move to range action. Let's add that stuff in there too, because we're making the stuff. So here's move to player action. We're going to copy paste, and we're going to make a move to range action. Move to range action, because we need that too. Move to range action. There we go. So move to player action, move to range action. Both of those are in. And we also need a ranged combat enemy. Let's do that. So we're going to rename all this stuff together. So we have a close combat enemy, which is up here, right? Here's our close combat enemy. let's rename it to or copy paste into a ranged combat enemy. Ranged combat enemy. So I'm doing all those because those are all the things we really need to add, ranged combat enemy, in order for us to make everything good. Now that we've made all the copies of the files, copy paste, then we want to add in the actions. So first let's add the action, add an existing item, and we want to move to range action that we want to add in here. So again, I'm just going to go here to move to range action and add it in. And as we go through, I want to rename it. So here, instead of move to player action, we're going to control F, and we're going to say move to range action is what this should be called. Move to range action, right? And we're going to kind of change them all. Good. And we're also going to change this to move to, up here at the top, move to range action. And we're going to kind of copy paste these in here and in here. So that just changes our guard function, which is cool. And the move to range action is pretty much the exact same here so far. Okay. We're still an action node and all that kind of stuff. Next, we're going to change the move to range action.cpp because we need that too. So move to range action CPP. Again, we're going to go to here, control F, and we're going to change this to move to range action and change all. Okay, there we go. And instead of move to player action, it's going to be move to range action, and it's going to say performing blah, blah, blah. And at the end, afterwards, we want to actually do the action. So get agent, and we want to move to range, whatever that is. When we program that, that is going to be the action that we do. In fact, all of the actions should have this now. So on that, we did the patrol action, which we made to patrol. We did the range action, which we just made. What about the other ones, like move to player action? That should also be able to do that. So we'll say, hey, get agent, let's move to whatever player. Let's move to the player. That is the actual action. When that is overridden, we should be able to do that. Same thing with move to line of sight, right? Move, hey agent, let's move to line of sight. We should do that too, right? Because we haven't done that. And on that, the attack action, well, hey agent, attack, right? So whatever that action is, and you can fill in the blanks there for you. So that is where all of those little actions go. So instead of doing a switch case, the decision tree does it for us. That's what it does. Okay, so that's all that. Let's go to git add dot, git commit -m, and we'll say added move to range action. And we've done other things too, but that's enough. Git push. We made all those changes. And we made those changes to the action nodes so that way they actually will do something at the end. Okay, that's good. Next. Agents we're going to get back to. I'm going to skip that for now. Let's go to the condition. That's easier. So the ranged combat condition I'm going to add in. So I'm going to add in an existing item to the ranged combat condition. Ranged combat condition. And the ranged combat condition dot CPP. So the H and the CPP. Ranged combat condition. So those two. Range combat condition, CPP. Add. And let's go do our renaming again. So again, I'm just going to control F, and I'm going to change this to the ranged combat condition. Ranged combat condition. Okay, and let's replace all. So that changes all that. And let's go up here to the close combat condition, as this is going to be called the ranged combat condition. So just a couple copy pastas there. There we go. And the ranged combat condition, in terms of what it does for now for us, instead of set is it's pretty much identical to within combat range. So that's not going to change. The condition is not going to change. All of this doesn't change. Within combat range, just different kind of combat range. Okay, that's the range combat condition. How about the range combat condition.cpp? Well, again, we want to change the names. Change all those. Those are good. And where it says close combat condition, let's just rename that to range combat condition. The rest remain the same. So that's kind of a very simple change. So there we go. So range combat condition is in. Wonderful. Now that we have the range combat condition in, let's add that into GitHub. Git add dot, git commit -m. I always do a clear instead of CLS. Added ranged combat condition. So we added that in. Git push. This is all prep for the range combat enemy, right? Then we want to make a change to the decision tree. So decision tree.h, remember this? We had our range combat condition and all that stuff. We have to add them in. So again, I'm going to do that before I do anything else. So decision tree in the decision tree.h here, I'm going to uncomment the range combat condition, right? Which allows me to import the range combat condition I just made. That's good. And I'm also going to uncomment this part, these two things I commented out, and as well as this part. These are all things that I commented out that I'm just going to comment back in now, because those are important pieces for all the things that we need for our ranged combat enemy to function. Now we need to put those in place. I'm going to go to my decision tree, and I'm just going to go here and generate definitions by declarations. I need to add in that getter and setter combo. All right, so let's finish them up. Add that in. And again, if I go to the get ranged combat node, right, which is this one, what am I going to do? Right, it's going to be return m_ranged combat node. Did I not make that ranged combat node? What did I do there? That is wrong. It should be this. So that just is a type error, I think. That should be down in here. Yes, I added in extra brackets. I don't need the brackets. Done. Good. That's just my typo. Okay, so that is that. And again, set range combat node. Well, that's just going to equal to m_range combat node is equal to node. So that is going to fix up the decision tree, because now the decision tree can do range combat as well, not just close combat. Let's put that up on GitHub. So again, I'm going to click on clear, git add dot, git commit -m, and we'll say added or modify. We'll say modify decision tree or ranged combat. Git push. Okay, so that's the thing we did there. And now we're prepped. We're ready to go for our. We can close down the decision tree. We can close down the starship. We can close down the patrol action, the close combat enemy, and pretty much most of these. I'm just going to close them all down. And what I want to do here is I want to add in the new agent, which is the close combat agent. So let's add that in. So right click, sorry, the range combat agent, add existing item. And we're going to add in the ranged combat agent. So let's go down to here, range combat enemy. There it is. And let's add it in. There it is. And let's rename it. So we're going to just rename this close combat enemy to range combat enemy. So Control F. Close combat enemy is renamed to ranged combat enemy. Ranged combat enemy. And replace all. There we go. And we also want to change this, ranged combat enemy. And this is where all our work is going to be now. Because once we've done this, then it's 90% done. 95% done. All right, so ranged combat enemy is identical to close combat enemy, but we need to go to my ranged combat enemy.cpp and modify that too. So in here, Control F, And we'll call this the ranged, oops. Control F, and we want to change that to our ranged combat enemy. Click change all, done. Now, the only thing I want to change in the ranged combat enemy for now, because it's identical to the close combat enemy, is the look and feel of the ranged combat enemy. So in the agents, so a couple things. In the CPP here, instead of using a small D7 as the thing I'm going to load, I'm just going to change this to a reliant small. So it's going to be reliant small.png. And then in close, instead of close enemy, we're going to rename the texture to ranged enemy. So it's a different texture. That's important. Make sure you make those changes, guys. Okay. The line of sight color, all this other stuff is identical. Nothing has changed here. And when we go all the way down, in terms of drawing, we want to draw the ranged enemy instead of the close enemy. Want to do that. This stuff doesn't change. The update doesn't change. None of this changes. That's why we wanted to make this change. If I scroll all the way down now, keep scrolling, and we go down to the build tree, this is where things are going to change. Why? Because, well, the ranged combat enemy and close combat enemy are different, right? Line of sight condition is the same. Radius condition is the same, but this is not the same. So there is no close combat node. We're going to change this close combat node. So we're going to control F, and we're going to say, anytime we say set close combat node, we want to change this to ranged combat node, set ranged combat node, right? That's what you want to change. Let's reset all of them. So that's one thing. But ranged combat node, should say ranged combat node. Ranged combat node can't be of type ranged combat close combat node, so that's also going to change. So anytime I say close combat node, let's change this to ranged combat node. Ranged combat node. Because that's going to happen. That's the change that we're going to make, right? We're going to change all those. The rest is pretty much the same. So let's just select them all. And this will be instead of a new close combat condition, this will be a new ranged combat condition. Ranged combat condition, right? There we go. Okay. So radius, ranged combat condition, patrol action, move to line of sight, and instead of a move to player action, right? Instead of a move to player action, we're going to move to range action is what this is going to be. So this is going to be a new move to range action, right? A new move to range action, which means we're going to have to add that in, the move to range action, right? And instead of us getting from we change all these, so it says get ranged combat node, which is good. And for the most part, with some selective find replace, I think we're almost good. Range combat, I think this is good. The exact same tree, but the only thing is that it's range combat instead of close combat. There's the range combat condition, and I just want to make sure that nothing else has changed. Well, here we don't need the move to player action because we're not going to do that. We're going to just move to range action. That's the difference here. All right, and that is our ranged combat enemy, right? It's identical to the close combat enemy, but it does different things. And we don't have other things we're missing, like move behind cover. We don't have that. Wait behind cover. We don't have that. Those are things, actions that we don't have yet, that we need to add in the actions. We don't have those actions. We're going to add them in so we can make those decisions. Okay, save. And now let's test the range combat enemy. And for the most part, it should act the exact same way as the close combat enemy, but it will not move to player. It should do the move to range action, which is exactly where we left off the last time. So let's go back into the placing.h. And here in the placing.h, we have our close combat enemy. Let's now include also the ranged combat enemy, just to be preemptive here. And then down where we have the starship being a close combat enemy pointer, let's just comment this out and comment or put this back in. So M_P starship is now going to be a ranged combat enemy. There it is. And in our CPP for our placing, we have to restate that the starship is not a close combat enemy, but rather, let's just copy paste here. Rather, it is going to be a ranged combat enemy. Ranged combat enemy, because that's the different type. Ranged combat enemy. There. Awesome. And then once we have this, it's a ranged combat enemy, then we can just play and it should do the exact same thing, but have a different condition pop up, which is where we want to stop for today. Let's try it. So start it and let's see if we're going to get any issues or if there's any problems or anything like that. And notice now we don't have to put in inside of the update function that switch case. We don't need to do that. The decision tree is our switch case. It's going to kind of go through and do that for us. Switch case was just temporary, right? So now it'll stop, right? And when it stops, it's going to say performing move to range action, which is what we want to do. And we can know that this is a different object because we've just changed the texture, so we can see that that is the case. But the exact same thing is happening. If I move this over here, as an example, let's move it here, then you can see that it's going to patrol. Notice that the line of sight is pointing towards our starship or our target, but it's too far, right? And even if it was closer like this, it doesn't have line of sight because of this obstacle. And so then it will just stop here, right? As soon as it gets here, now it says move to range. Well, it'll move into a range position to fire its bullets or whatever it's going to be, right? That's what it would do. And if I was going to reset this just for a second and run it one more time, and once we did this, and if I was to move the obstacle around, so again, you can see that there's obstacles here, and there's obstacle, that's the thing. There's this an obstacle, we can move that around. Every time I move the obstacle, this moves too, right? And then this obstacle here. So what if I move this obstacle so it's up? So it's not there, but actually it's up here somewhere, okay? And then if I turn the grid on, you can see that the grid is going to be active. So let's see how it's going to respond differently when I do that. If I take my object and let's put it down somewhere else. So again, I move my target down. And I move my target down so it's going to be somewhere over here. You can see that now the patrol is going to happen, but it's going to have line of sight a lot faster because there's no nothing that's going to block it. Watch. As soon as we got line of sight. Even though, okay, and here's something else. All of these nodes, right, it says somehow does not have line of sight. That's kind of weird, isn't it? These nodes should all have, these nodes should all be green. Well, it's to the target, this is to the starship, and this is to both, right? So that is something that's broken because before both was working and now it doesn't, okay? So that's something that should be working here too. I'm not going to troubleshoot this though because we got the behavior we want, which is, hey, I'm within line of sight. I know that this is good. I can be able to fire my bullets, no problem. But that is kind of weird behavior because this is only from this to the starship. But what about all these? These are also available to come here too, right? So that is something that's going to be, that's changed. Something changed. Okay, guys? And the way to know that is because, look, only these things are available. But no, it shouldn't be just these. What about all of these? All the ones that are away. So, again, if I move these around, right, and I move them up, let's say I move these up here, well, we should be able to draw lines to all the other nodes here that have line of sight. So let's move that. Sorry, let's move that around. So now you can see that all of those open up, right? But what about this one? What about this one? right? Right, this one to this. So it could be the distance that we're talking about, right? So this is the line of sight distance, and you can see that this is weird. Look at that. So this is an issue. This is what it should look like. It should go like this. So when I go up to about here, 536, take a look at that, right? That's what it should be. So there's some kind of calculation error happening right now where some nodes, for whatever reason, beyond a certain point, don't have line of sight. Take a look at that. That's like a calculation issue. This is kind of like what it should look like more, right? Because if I move these around, right? If I move these around, then all of those nodes to a certain distance should be okay. But look, that's kind of something that's happening. So as soon as I move those nodes around, then I lose line of sight with some of the other ones. So there's something wrong with what we did before. I'm just pointing this out. This is a bug I just found. All right. So maybe it was something the way we did it. And if I look here for the first time, and if I was to go here, the grid actually only shows nodes that have line of sight because of where I'm positioned. So what if I move my ship? I'm not moving the obstacles because that's where it seems to be the issue. Let's move my ship around. So not this one, but this one. That makes more sense now. But what about over here? Does that have line of sight? You know, with my ship, you know, it seems that this one should have line of sight too. This one, but it's like something to do with my path node distance for each of the path nodes is causing an issue because this should have line of sight all the way to here, right? That is what it should look like. So something is wrong. It's not exactly working perfectly, right? So what could be the problem if we're going to troubleshoot this, right? Because how do I know that each of this is a path node thing. This is not even a line of sight thing for my ship. This is working. The goal for today is met, okay? But what I'm saying is, what about the path node line of sight thing? How does that work? And remember that the path node line of sight it uses that other method we had before, where we check the path node line of sight up here. It says, I'm going to take, for me to check the path node, here's my my things that I was doing. I'm saying set current direction to the normalized direction, and then check the agent line of sight with the path node. So wherever is from the path node to the target. Path node to the target. Okay, cool. So here's the target direction. Target direction is the target position, which is my middle enterprise, minus the path node position. That is that. And then I'm normalizing it. And normalizing, basically what it does, it takes the target direction and sets it to a value of 1. That's the direction. And then it says path node set current direction. So it looks at the normalized direction. And then I'm calling the check agent line of sight. This is the one, check agent line of sight from my path node to my target object. And this is why I need that check agent line of sight thing that I had before. Okay? So that's what I needed here. So something might be wrong with my check agent line of sight check, because otherwise they should be working, right? So let's go there. So go to definition for the check agent line of sight, and this is where it is. Let me just check my notes, because maybe this is an issue that we've always had, and that would be not good, right? Because that is something that is an issue, and I'm going to figure this out, because we can troubleshoot it on our own. All right, so that has line of sight. Yeah, I think I'm going to make some changes here. So our check agent line of sight, we don't need the line of sight color, so we'll get rid of that like we did before. And I'm just going to, so remove that for now. We don't need that color. Line of sight color can be removed. So that's not something that we need. Again, just checking notes, guys, just to make sure that we're good. And then we're saying that if my agent to range is get closest edge from a get transform position to the target object, that's correct. Then whatever that target object happens to be, then agent to range is less than the agent line of sight distance, agent being the thing. If this is true, less than or equal to, we're in range. Okay. Make a contact list, get to display list. I'm just going to go through here again. If, maybe we should say something like, if the object, display object, right? If the display object is equal to none, right? So that is the, if the object type, get type, is equal to none, this one, then we want to continue, which is kind of what I said in the other one, right? So that's one thing we want to do. We want to continue there. And if the agent to object distance is get closest edge from the agent transform position to the display object, that's good. Okay, and then if the agent to object distance is greater than agent to range, we want to, the target is flipped out of range. Well, here I'm saying the target is in range. And if the agent to object distance is the distance between my agent's position and the display object. If it's outside of that distance, then don't do this. Otherwise, check agent path node. I think this is all the same. And not target. Yeah, this is good. Push back to the display list. And then agent line of sight endpoint is equal to that. As line of sight is line of sight check with agent to line of sight endpoint, contact list and target object, and we want to set the agent has line of sight here, right? And that's only if I'm within range. And what we did, here's what we did differently. What we did for the contact list, what's the problem with the contact list you get? What are you thinking? Your contact list. Not sure yet. Okay. But what we did for check agent line of sight for our object, for agents, if I look at agents and we compare side by side with our close combat enemy.cpp, we actually did this. We can actually pull this aside and do a side by side comparison of our check agent. Actually, it's not here. It's the agent. It's in the agent method. It's in the agent method, just a moment. So we are going to go to core agent.cpp is what I wanted. Which is this exact thing. This is the exact same thing, except we put the agent has line of sight down here. I wonder if that's just going to check that to make sure. That's that. Here's my agent. And let's just do a side-by-side comparison. I like doing this sometimes because, you know, we made some changes to one, but we didn't do it to the other one. It's the same. Okay, we did the normalized direction, but we saved the direction inside of there. Okay. But that would be setting up the line of sight, which we don't need to do here. And then agent to range was the exact same. Get line of sight distance, get transform position, get closest edge. Yeah, that's the same. And that's the same. It's the same. That, we're not pushing it back because we're checking all of them. And then we're saying after we do the check. That's the for loop. Inside the check, we're saying has line of sight is this line of sight check with that. And we do this check here. Oh, so this check is actually done out here. I mean, it doesn't really matter. I don't think it's going to matter, but that's the difference. That's the agent to line of sight distance. And actually, this shouldn't be agent because this is the agent. We can just do this to make sure that that's the difference. Agent to line of sight distance. So this is save. And line of sight with the agent, well, that's line of sight checked with this because that is the agent, and the endpoint because this is the agent object. Save. Oh no. Oh no, that was correct. Undo. Agent, because we're passing in the agent to another agent we're talking about. All right, let's try that again. So if I was to try that with just that one change, I don't think there's a big difference here, but let's see what it's going to do. And again, I'm going to troubleshoot this later on. If I don't do it now, I'm not going to waste time. But that's better. Look at that. So it sees all that. That's how it should see it, right? And what about if I move my ship now? I move my target. That's where things change, right? That's way better. Look at that. What a difference. It's like light coming out of the ship. That's what it should be. So these are all good. And now what if I move the obstacles? The obstacles was where things changed up a little bit. So that's exactly how it should be. There you go. That's the bug. That's the bug. Yep. That's it. So that's how it should work. That's why I noticed something was wrong, because I was like, wait, what? No. Look at that, right? That's because all of these should be able to see it, right? And I noticed, I guess we didn't see that last time. That was a bug that's been there from the last time, right? Look at that. That's a bug. So that's how it should work. See how like this one over here should see it. And see how that stopped? Because now I have line of sight. But what if I put an obstacle in the way, kind of thing. So if I move the obstacle in the way of this one, you see that none of those have line of sight. And this thing is going to travel to a point where it has line of sight. And it should pretty much match with these things, right? So it's not going to go there because it's patrolling around. It's not going to meet there. So guess what? Even though these have line of sight, it's not going there. It's going around to patrol, and it's going to find a spot in the patrol radius where it's going to move to player. We don't have a move to line of sight. That's not something that we've done, right? Just patrol and stop, right? Awesome. That's how it should work, guys, and that's fixing that problem. So I know I ran over time, but I fixed my issue, and this is the issue that I fixed. I moved it here, and I also changed this part here, which is if the game object is none, it doesn't add it to the contact list, which means that's good. All right, so now this is all good to go, and let's put this up on GitHub. Absolutely, Kayla, always. So git add dot, git commit -m, and I'll say fixed line of sight bug node, path node, line of sight bug, and git push, and that should push everything up. So that is the final version of the lab. Anybody have any questions and about anything? So again, the last thing we did was we figured out at the end that there was a bug in the code. And sometimes this happens, like you're coding and everything's great. And then you're like, wait, that's not supposed to be like that. And that's been around since last time. I just didn't figure it out. I didn't see it, right? But now I saw it and everything is working great. So again, whenever you want to test stuff, now this is the ranged combat enemy, like we said. So here's the ranged combat enemy. This is from our code from today. You can see it only turns on now when we see it, and we see the great line of sight that we're seeing here as before, right? And if I want to switch it, the way to do that is to go into the play scene for now, and then in the play scene, switch it out of the close combat enemy and switch in the ranged combat enemy, right? Or the other way around. Switch in the close combat enemy, switch out the ranged combat enemy, but you also have to do in the placing.cpp, you got to switch the type. Now, this is for now. Here's a question for you, lovers of OOP. How do you make it so that you don't need to switch it? How do you make this so you don't have to switch it? Like the type, this type. So I only have to do it once. So first of all, let's test to see if this does exactly what we said it's going to do now. I'm just testing it back again one more time to make sure that it works. And then if it does, then we're good to go. And then I'll talk about how to fix it. I know we're over time. Bear with me. If you're still with me, that's good. Because if we look here, toggle the grid on, the grid works nice. And it says move to player. So now this thing would move to player and ram me. Ramming speed, right? This thing would try and ram me. Because that is a close combat enemy, let's say, right? But how do I know? How do I make it so that I don't have to switch it? Well, if I go to my placing.h, we know that the starship is an agent. So what if I specifically said that this is an agent type? Is that allowed? Can I do that? If I said, instead of this, I said it's an agent. And if I did the same thing here, agent, right? If the starship is an agent, right, as an example, then it really doesn't matter which I put onto it, right? I mean, it's just going to be the agent that I'm going to define later. So I would never switch it here. I don't have to switch it here anymore. I could just switch it in the placing. So in the placing is the only place I'd switch it. So here. And notice that close combat enemy is a agent because that's what starship is. So maybe this should work. Let's see if that works. And this is called downcasting, right? Or is it going to mess up? Yep, you got it. You get. And it messed up, right? Because it says class agent has no member get tree. Huh? What? How's that possible, right? Agent. If I go to, now here's something else, right? Up here, we never instantiate, or we never included agent. Let's include that. Include agent.h. And let's just not include these includes for now. Well, actually, we have to include them because, well, not maybe here, but just to say, so agent's pointer, if I was to change this to agent pointer and, in the placing, and we said that our starship is an agent pointer, that's what it is, then how come in my placing.cpp, when I instantiate it, and this is the only thing we made a difference to, it's telling me that close combat enemy doesn't have a a get agent, because that's what it's telling us. Here's get tree, right? Here's get tree, and get tree is of type decision tree, right? But agent does not have that, right? Agent itself, that's the only difference. If I go to the core, or sorry, the decision agents, and if I go to, or sorry, core, and if I go to agent.h, where is there a get tree in this, right? Because right now, the way we've coded our agent, yeah, it has a bunch of actions, but where's the tree? Tree doesn't live here. The tree lives in our combat enemy specifically, as well as inside of our range combat enemy. So if we wanted this to work, we would have to update it. We could dynamic cast it too, but we could update it so that all agents have a tree. Right now, all agents don't have a tree, but they have all this, right? They have all this, but they don't have a tree, which kind of is like, why, right? So that's something we can change, not today, but later if we wanted to. But to go with what Yigit was saying, if I go back down to here, if I was to cast this, right, So Starship, if I'm going to cast it as whenever I do a get tree function, because that's what I'm trying to do, because agent's going to try and get my tree and all that stuff. I looked at that. If I go search and if I do a get tree, you can see that get tree for my Starship in the update doesn't exist unless I cast it, but then I have to change that every single time. So that's why for now, we're not doing that. But realistically, all agents should have a tree, right? And therefore, get tree should not be part of combat enemy or ranged combat enemy. It should be part of the agent class itself going forward, okay? We're not going to do that today because we run out of time already, but that's the reason why it doesn't work the way it works. So going back to this lovely idea that we had, yes, this will work, but not today. So this will be the close combat enemy. And then we'll do the other one. We'll copy paste it for the ranged combat enemy, right? Okay, and we'll just comment one out. So if we want to do the close combat enemy, which is how we started, then that's okay. Then inside the placing.cpp, now it computes, and it computes because we're all good to go. Any questions around that? Because that is a object-oriented programming problem, right? That we've kind of put into place because agents don't have trees when they should. That's it for me. I'm going to put this up on GitHub. So I'm going to say git commit -m. We'll say final version of lab 7.2 git push. So that way you know where we're stopping. Okay. I'm going to stop recording now and I'll take some questions or any concerns you might have. All right, questions or concerns?